Hello, my name is John Cody. I have a background in engineering. Today we'll be continuing our exploration of the quadria of the projective quadrilateral. This is part 2 in the series. So the setting is we have a projective triangle, A1, A2, and A3, with side quadrants all equal to 1. So Q is equal to 1. The side quadrants on these three sides is 1, and also the spreads at the three corners of the triangle are all equal to 1. In addition, the quadria of this projective triangle is Q times S times Q, which is equal to 1. And we also have a projective point inside this projective triangle. So that's the setting we're working in. So what we do is we form a quadrilateral A4, A5, A3, A6, consisting of these 4 points. And it's inside the triangle A1, A2, A3. And what we've done is we're adding lines passing through A1 and A4 and A2 and A4. So these two lines here. And previously, we found out in previous video, we found that the spread S here is 1 minus AB. A is the quadrants of this side, between A6 and A3. B is the quadrants between A3 and A5, and C is the quadrants between A5 and A4, and D is the quadrants between A4 and A6. So previously we calculated the values of C and D in terms of A and B, and that this is the result right here. So now we're going to add this line going through A3 and A4. So so we have new values of E here and 1 minus E there. The quadrants between this point A3 and the intersection over here is 1. So E is by the quadria of this projective triangle A1, A2, A4. The triangle here is by the formula for the quadria of that, it's this side times the spread S times the quadria of this side. So it's 1 minus C times 1 minus D times S. Okay, so we're going to substitute for C, D, and S from the above, and we get E is 1 minus A times 1 minus B divided by 1 minus AB, and 1 minus E is A plus B minus 2AB, all divided by 1 minus AB. Also from the spread law, we get 1 minus F, the value here, and that is the 1 minus F, because these quadrants are both equal to 1, that 1 minus F there is equal to the spread down here. So by the spread law, we have 1 minus F, the spread here, divided by D equals 1, the spread here, divided by 1 over E, the quadrants of this segment. So 1 over F is D divided by 1 over E. Or sorry, D divided by 1 minus E. And then we substitute for D and 1 minus E from the above, and we get 1 minus F equals B times 1 minus A, all divided by A plus B minus 2AB. And rearranging, we get F is A 1 minus B, all divided by A plus B minus 2AB. Okay, next we're going to calculate the sum of the quadrias of 3 projective triangles, A1, A2, A4. So the projective triangle A1, A2, A4 A2, A3, A4, the projective triangle here, consisting of points A2, A3, and A4, and the projective triangle A1, A3, A4. So the three projective triangles, this one, and this one. So the quadria of the A1, A2, A4, the quadria of A1, A2, A4 is the base. There's a formula that says it's the base here, the quadrants of between A1 and A2 times the altitude E. So the quadrants between A1 and A2 is 1, and so that works out that the quadria of A1, A2, A4 is equal to E. Similarly, for A2, A3, A4, this quadrants between A2 and A3 is 1, so you multiply that by this altitude C and you get C. And lastly, the quadrants for A1, A3, A4 is the quadrants between A1 and A3, which is 1 times D. So, and now we're going to calculate, we're going to sum these three, and to get the quadria, we're calling A of the quadria of the three projective triangles. So A is C plus D plus E. And substituting for C, D, and E in terms of A and B, we get this is the C formula we had for C. This is the formula we had for D, and this is the formula we had for E. And if we do a little algebraic manipulation of these, we arrive at this result, which factorizes to, or simplifies to 1 minus AB divided by 1 minus AB, and that gives us a value of A equals to 1. So we sum the sum of the quadrias of the three projective triangles is 1, and that's the same as the quadria of the larger triangle, the triangle A1, A2, A3. So there's three triangles inside, and they sum the quadria. If you sum those three quadrias, it's equal to the quadria of the larger triangle. Okay, so we also have these smaller triangles. For instance, for triangle A2, A3, A4, you have this smaller triangle here and over here. And if you sum the quadrias of those two, you'll get B, 1 minus B times C plus B times C, which is equal to C. So these two smaller the quadrias of these two smaller triangles adds up to the quadria of this A2, A3, A4. And the same applies to the other sides as well, these smaller triangles here. So the sum of the quadrias of these 6 triangles adds up to 1, which is the quadria of the larger triangle. Next, we will calculate the sum of the quadrias of the 3 projective quadrilaterals. So that's A3, A5, A4, 6. So A3, A5, A4, A6. That forms a projective quadrilateral, these 4 points, and it, as well as A5, A2, A7, A4, that forms another projective quadrilateral. And A1, A6, A4, and A7 forms a third projective quadrilateral. So we're going to sum those 3 up using the formula for the quadria of a projective quadrilateral having 2 adjacent spreads both equal to 1. And I covered that in the last video. So the spread here is 1. The spread here is 1. So we can use the formula for for that special case, it's going to be d times A plus A times B minus d times A times B. So that's the quadria of the quadrilateral A3, A5, A4, A6. A3, A5, A4, A6. And the same thing applies to the other two quadrilaterals. So the second one is A5, A2, A7, A4. A5, A2, A7, A4. It's going to be C, this side here, times 1 minus B, plus 1 minus B times F, right here, minus C times 1 minus B times F. That's the quadria of the second quadrilateral. And lastly, we have A1, the quadrilateral A1, A6, A4, A7, and the and this also has spread here is equal to 1, so there's two adjacent spreads equal to 1, so we use that same formula. It's going to be E times 1 minus F plus 1 minus F times 1 minus A minus E times 1 minus F times 1 minus A. And we add those three, the quadria of those three quadrilaterals, and it results in this, substituting these values or just adding those values all together, results in this formula. Now we do the same thing. We substitute C, D, E, F, and 1 minus F from that we determined earlier in terms of these values of C, D, E, F, and 1 minus F in terms of A and B. And using some linear algebra software and a computer, we get A, the quadria of the sum of these three projective quadrilaterals is equal to this expression. And when we factor it, we get A is equal to AB minus 1 times 2AB minus A minus B, all that divided by AB minus 1 times 2AB minus A minus B. So the numerator and the denominator in this expression are equal. So that means that the quadria of the sum of the three projective quadrilaterals is equal to 1, which is the same as the sum of the quadria of the three projective quadrilaterals, this one, and this one, those three projective quadrilaterals, when you add the quadria of those together, those three together, then it's equal to the quadria of the large triangle A1, A2, A3, which is 1. So that was using the formula for the quadria of the projective quadrilateral where the spreads has two adjacent spreads equal to 1. And lastly, we will calculate the sum of the quadrias. We'll do the same things, but we'll use the formula for when we have three spreads, three adjacent spreads in a quadrilateral equal to 1. So we're going to do the same. We're going to add up the quadria of this quadrilateral, and this quadrilateral, and we're going to use the formula for when there are three spreads in the quadrilateral equal to 1, which is what we have here. So each of these quadrilaterals has three spreads equal to 1. So when we substitute so it's going to be for the first case, we just plug it in this formula. It says this side, quadrants of this side A and B, we just plug them into that, and we get the first one here. For the second one, the sides are 1 minus B and F, and when we plug it into the formula, we have this expression for the second quadria, and the third quadria of this quadrilateral, the sides are 1 minus F and 1 minus A, and we plug it in again, and we get this expression. So we're going to we'll let A equal the quadria of the sum of these three quadrilaterals. We'll do the same thing, and we'll substitute into these expressions what we had for C, D, E, F, and 1 minus F. And using some linear algebra software on a computer, we get A is equal to this numerator value divided by this denominator value. And we see that the numerator and denominator are equal. So again, the quadria is equal to 1 when we sum up the 3 quadrias of the projective quadrilaterals. And that is equal to the quadria of the triangle A1, A2, A3. Okay, so that's it for part 2.